Welcome to Cosmos Game. I'm your host, Cosmos. Today we'll be doing Class 12, Chapter 1, Physics, Electric Charges and Fields. To begin with, let us start with what are electric charges. To know electric charges, consider an object that consists of particles in it. When an external force or field is applied to it, due to the effect of the force or field, this particle starts moving, and because of this motion, electric current is produced. Then this particle, whose movement produces electric current, are called as charges. So we can define electric charges as particles whose movement under the influence of an external force or field produces electric current are called as charges or electric charges. Charges can be of two types, that is, positive or negative. Let's take an example of positive charges and negative charges. Example of positive charges. Example of positive charges: protons, cations. Example of negative charges: example of negative charges are electrons, anions. The SI unit of electric charges, SI unit of charges. The SI unit of charges is coulomb. In short, it is capital C. Charge are denoted by either small q or capital Q. There is an instrument used to measure or detect our charges. So the instrument used to measure charge is leaf electroscope. The instrument used to measure charge is gold leaf electroscope. There are two natures of charges. First, like charges, repels one another. To get this idea, let's take a positive charge and take another positive charge. A force will be acting between them, and the force is going to be a repulsive force. They will push one another away from one another. So, like charges repulse one another. Similarly, if you take a negative charge and another negative charge, they will repel one another. So this is the meaning of like charges repulse one another. The second point, the second nature, unlike charges, repulse unlike charges attract one another. To get the meaning of this, let's take a positive charge and a negative charge. There will be a force acting between these two, and this force is going to be a force of attraction. They will pull one another towards each other. Similarly, a negative charge and a positive charge will be attracting one another, that is pulling one another towards each other. So these are the two nature of charges. Now, let's talk about the properties of charges. Properties of charges. The first property is charges are additive in nature. Let's talk about it. I have a system of charges consist of Q1, Q2, Q3, Q4 till Qn. I want to get the total charge in this system. Let's say the total charge is Q. Then according to this property, charges are additive in nature. The total charge of the system will be given by the algebraic sum of all the single charges in the system. That is, Q is going to be equal to Q1 plus Q2 plus Q3 plus Q4 plus dot 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 plus Qn. I can use it in the form of solution, where I is from 1 till n. To use this particular property, let's say an example, find the total charge consists of the following charge. One coulomb, 2 coulomb, 3 coulomb, minus 4 coulomb, minus 6 coulomb, and minus 1 coulomb in a system. To find the total charge in the system, I'll use the first property, that is, charges are additive in nature. The solution is going to be here Q1 equals 1 coulomb, Q2 equals 2 coulomb, Q3 equals 3 coulomb, Q4 equals minus 4 coulomb, Q5 equals minus 6 coulomb, and Q6 equals minus 1 coulomb. To get the total charge, I'm going to use the formula Q equals Q1 plus Q2 plus Q3 plus Q4 plus Q5 plus Q6 equals Q1 value is 1 plus Q2 value is 2 plus Q3 value is 3 plus Q4 value is minus 4 plus Q5 value is minus 6 plus Q6 value is minus 1. I plus all the positive number, it becomes 6. I plus all the negative number, it's going to be 11. So the total charge in the system is minus 4 coulomb. So this is how we are going to use this property. For the second property, charges are conserved. To get this idea where charges are conserved, I take a charge as a whole. The total charge of this is, let's say, example, 10 coulomb. Now in this system, I break this charge, single charge. This is single. I break this single charge into different charges, into smaller charges. The sum of all these charges should always be equal to the single charge where it breaks into. Let's take an example here, 2 coulomb, 5 coulomb, 3 coulomb. Now when I plus Q1, Q2, Q3, I get the same total as 10 coulomb, which means while breaking down a single charge into different charges, there is no loss or gain of charges, which shows that charge remains the same as a single or as it breaks off. So the value remains the same, the charge remains the same, therefore charge are conserved by nature. In other words, I can say that charge can neither be created nor be destroyed in an isolated system. So this explains the second property, charges are conserved by nature. So in order to write this in words, it states that the total charge of an isolated system remains constant. Or in other words, charge can neither be created nor be destroyed in an isolated system. Coming to the third property is charge is quantized. What is quantized? You take a larger piece of something, if you can find the smallest particle that joins to build up this whole thing, then this single particle is called as quanta. So charges are quantized by nature. That means it can be break down to get the smallest charge that builds up a large charge. So what is the smallest charge that is found in our substances or conductors? Now, in general, we take electron, which is negatively charged, to be the quanta of electric charges. So, as I take a very large charge here, I'll find that this charge is made up of electrons in here. So, since these electrons are the smallest particles that builds up the whole charge here, this electron is called as its quanta. Thus, since it has a smallest quantity, charge is quantized by nature. Let's try to write it in words. So, charges are built by a group of electrons in solids. Since electrons are the smallest charge that builds the total charge, we can say that charge is quantized by nature and electron is the quanta of charge. It is experimentally found that the charge of electrons, which is denoted by E, E means charge of electron, and it has a value, it has a magnitude. E is equal to 1.6 into 10 to the power minus 19 coulomb. One electron, that means one electron carries 1.6 into 10 to the power minus 19 coulomb. Now, in terms of the nature of charge, we have positive and negative charge. So, in terms of kind of charge, electrons will be negatively charged and it will have a value of 1.6 into 10 to the power minus 19 coulomb. Proton has the same charge, but it has positive charge. This is for electrons. Now for proton, it will be plus 1.6 into 10 to the power minus 19 coulomb. This is for proton. So together, electron and proton, since they have the same charge, in general we can write E equals plus minus 1.6 into 10 to the power minus 19 coulomb. Depending on whether it is an electron or proton, we're going to use plus and minus. But as I said, if it is just magnitude, we never consider plus or minus. We just use the value to calculate. In continuation, let's say we have a charge here, total charge Q. There are going to be electrons that build up this, which is its quanta. Now, in order to find the total number of electrons in here, we can use the formula Q equals NE, where Q is the total charge N is number of electrons and E is magnitude of the charge of electron. Now using this formula, try to solve this question. In our next topic, let's study how to charge an uncharged or neutral body. That means a body which is neither positive nor negatively charged. The first point, we can charge an uncharged body or neutral body by rubbing it with another body. By rubbing it with another body. Let me show you an example here. Let's take some pieces of paper. These are some pieces of paper. This is a pen. I put it in my hand. If this one is charged, or if the pieces of paper are charged, they will attract or repel one another. Let me try it. I see no attraction, neither repulsion here. So I'll try to charge my pen by rubbing it with my hair. Now let me see whether it gets charged or not. You see that the paper is being attracted by the pen. It is because after rubbing the pen with my hair, This pen gets charged. So after rubbing it with some other body, the neutral body, in our case, the pen, is being charged. So by rubbing it with another body, we can charge an uncharged body. So how does it get charged? The one, when I rub two objects, a neutral body with another body, the body which is losing electron, is positively charged, and the body which is gaining electron from another surface, from another body, is going to be negatively charged. In our case, the pen loses electron on its surface to my hair and it becomes positively charged, whereas my hair becomes negatively charged because it is gaining electron from the pen. That is how an uncharged body is charged, by rubbing it with another body. Let's write it down. We can charge an uncharged body by rubbing it with another body. The body that loses electrons on its surface becomes positively charged, whereas the body that gains electrons on its surface on rubbing is negatively charged. For different objects and substances, the positive and negative body or substance depends on which type of material it is made of. We'll discuss them with a table here. So as I said, depending on the type of material which are getting rubbed with one another, the positive and negative charge will depend on the material. All those material made of fiber are positively charged except silk. For example, materials made of fiber such as wool, fur, hair, all those when rubbed with any other material will become positively charged except for silk, which is a fiber, but it is negatively charged. As you see from the table, All the materials made of fibers such as woolen cloth, fur of a cat, hair are always positively charged, and the other materials are going to be negatively charged, which means our material made of fiber are losing electrons while rubbing, whereas the other materials gains electron while rubbing. Except for silk, which is negatively charged, that means it is gaining electron, whereas the other body becomes positively charged because it is losing electrons. The second method to charge an uncharged or neutral body is charging by induction. Let's try to discuss it in a simple way. Let's take a charged body here and bring an uncharged body. Let's say it is positively charged here, and this one is neutrally charged. A neutrally charged body has equal number of positive and negative charge, whereas a charged body has either majority positive charge or majority negative charge. When I bring a charged body near an uncharged body, due to the effect of this charged body, the negative charges on the neutral body will come towards the negative charge. The negative charge will come towards the positively charged body, and the positive charges will go to the opposite end, making the neutral body a dipole where one side is negatively charged and the other side is positively charged. Now this neutral body, after bringing this charged body, is being charged. One side is negatively charged and the other side is positively charged. So this method of charging a neutral body, when a charged body is brought near to it, is called as induction. You can touch this charged body to the neutral body, or you can bring it near to it. It gives the same result. So in this way, we can charge a neutral body by bringing a charged body near to it. Why does these negative charges come this side and the positive charges goes that side? It is all because of the nature of charges. Since negative charge are opposite charge to positive charge, they will attract one another, and all the positive charge will try to move towards the positive charge, whereas the positive charges here, which are like charges, will get repelled and goes to the opposite side, which gives us a dipole in this neutral body where one side is negatively charged and the other side is positively charged. So this is how a neutral body is being charged by the method of induction. Let us write in short. So when a charged body is brought near an uncharged body, due to the effect of the charged body, the charge in the uncharged body gets redistributed and becomes charge. This method of charging is called as charging by induction.